Hi, my name is Valeria and I'm Paola, and we are presenting problem number 6. So mutually exclusive means that two events cannot happen at the same time. So here we have an example. For example, getting tail and a head when flipping a coin. It is mutually exclusive because you can only get a tail or a head. So the second example is finish a project within Monday and Friday and finish a project within Thursday and Sunday, and it is not mutually exclusive because they both can happen at the same time. Exercise C asks if events A and B are mutually exclusive. To find out if they are, you need to do this formula. So you would just multiply the probability of A times the probability of B. And once you do the multiplication of 1 over 2 times 3 over 10, it would not give you 1. If it doesn't give you 1, it won't give you 0. If it doesn't give you 0, it's not mutually exclusive. So event C is not mutually exclusive. No. Not. Ok, ahora digo el siguiente, y así. Sí. Ok. Now, event D asks if B and C are mutually exclusive. So you would use the exact same formula. So B and C, 3 over 10 times 1 over 5, it won't give you equal to 0. So this is not mutually exclusive as well. On event E, it asks if C and D are mutually exclusive. It would be the exact same formula. So 1 over 5 times 2 over 25, it's not equal to 0, so it's not mutually exclusive. Also, we need to consider that all of this set of exercises, we're considering that they are that they are independent, so that's why they are not mutually exclusive. Then, for exercise F, it asks if P of A or C is equal to 3 over 5. Exercise F, it asks if a probability of A plus probability of C minus the probability of A and C would give 3 over 5. If you follow this formula, P of A plus P of C minus P of A and C, considering that this is A and this is C, it would exactly give you 3 over 5. So letter F would be true. And then for G, you would do the exact same thing we did from A to D. So you would just multiply 3 over 10, which is B, times 1 over 5, which is C, and it would not give you 0, so it is mutually exclusive. It is not mutually exclusive.
My name is Erika.
And my name is Belisa. And today we're going to show you problem number 2
About binomial distribution and Garcia. Hello, today we're going to present problem number 2 of the project that the problem says. You have a bag with 80 chocolates Hershey's, 30 chocolates Hershey's almond, 27 Hershey's milk, and 23 cookies and cream. If you randomly pick 2 chocolates, find what would be the probability if the both you picked were cookies and cream. So for that, we need to make the probability distribution table to know, for example, if you pick 0, 2 times, if you pick 1, there would be cookies and cream, and if you pick 2. So this is what you do first. You do the chart with see if you pick 0, if you pick 1, and both chocolates. And remember that the goal is to find this. Well, the first one, x equals 0. If I take 0 that are cookies and cream, the probability will be 57 out of 80 times 56 out of 79. That means that this is 399 over 790. If you don't remember how much chocolates we have from cookies and cream, we have 23 over 80. From milk, we have 27 over 80. And from almond, we have 30 over 80. So we're basing on these 3 numbers, right? Okay, now we want to find this number. X equals to 1, and we made 2 picks because we're going to take 2 chocolates. X equals to 1, if we take 1 chocolate, would be 57, the first pick out of 80, times the second peak, that this could be a cookies and cream, that is 23 over 79, plus the second peak, we're gonna make 23 chocolates that could be cookies and cream, times the 57 that can't be cookies and cream. And this gives you this number. And now for the second, if this is our goal, if we find 2 cookies and cream, we make x equals 2, then we're gonna have yes and yes, right? So it's gonna be 23 over 80, those are the 23 cookies from cookies and cream, times 22 over 79, 79 because I already took one of these out, and the answer will be 253 over this. So question A tells us how many, what will be the probability if we take that both there are cookies and cream, and this would be that.
In order to identify the probability that at least one of the chocolates chosen is a Hershey's cookies and cream, we have to multiply the probability of 1 and the probability of 2. Therefore, we will do the following. Times x. Which will give us 391 over 790, which is 0.4949. Question number C asks, the random variable x, number of chocolates, Hershey's cookies and cream, results in a binomial distribution. The answer would be yes, because we already have the probability in the distribution table. Question D asks, if there is a binomial distribution, determine the values of n and p. Now, n is a total number of chocolates we have, which is 80. And p, which is a probability, we can have 3 different probabilities. For cookies and cream, which would be 23 over 80. For milk, which is 27 over 80. And for almond, which is 30 over 80.